In this video, we're going to look at models in the design process. We're going to study a handful of model types and figure out when they get used in the design process and for what reasons that they get used as well. So why bother using models in the design process? Well, models are an improvement over a sketch. They're 3D and they help us to understand the designs that we're trying to come up with. They help other people understand their ideas as well. Now, more specifically, we use models in the design process to generate and explore ideas because they're quick to produce. We would use models which require cheap materials. These models tend to have low detail and they tend to back up or supplement the sketches that we've already done. So for using models to generate and explore ideas, we tend to be looking for more of a sort of quick model making method. We may also choose to use models to test and refine our designs. So our designs have gotten beyond the idea stage. They've got a little bit more detail on them, and we may use models to test their ergonomics or to check which parts fit against other parts, that everything's moving properly. And at this stage of the design process, it's conceivable and probable that we will make lots of models. We will be, as they say, iterative, which means we make something out of a model, we change it, we make another model, we change it, and we keep going. And slowly and surely we refine our design. We can also use models to communicate our ideas and our designs as well. And if that was the case, we'd be looking for model types where it's all about the final appearance. These models tend to be accurate, they tend to be very well finished as well. And the sort of people that we might be communicating our designs to are the likes of manufacturers trying to explain how something is to be made, or perhaps it's customers and for marketing reasons as well. Those 3 bullet points there, generate and explore ideas, test and refine designs, and communicate designs, are the scaffolding around which you can answer any exam question about model making. And we'll cover some more of that later on. We're going to look at 6 model types in total: sketch models, block models, scale, test models, prototypes, and computer generated models. Let's take a look at each of those in turn and start off with the sketch model. Now, a sketch model has got nothing to do with sketching, it's got nothing to do with drawing or anything like that. It's called a sketch model because, like a sketch, it's quick to do, almost disposable in nature. So a sketch model is a type of model which is produced very quickly from cheap and abundant materials, usually at the start of a design process, usually to visualise early ideas. And it's useful for checking the scale and size of things, it's useful for checking for anthropometrics, it's useful for checking some functional issues, such as stability. And I'm looking at the photograph here of these models, which are models of a phone stand. We could determine from those sketch models that a phone could fit on the model fine and that it wouldn't fall over. We can check, in a limited way, we can check for moving parts and mechanisms, not really with paper and card, but for some sketch models that might be possible. And finally, we can use the sketch model for aesthetic factors as well, trying to figure out how beautiful the model is. Our next model type we're going to look at is a block model. Now, a block model is so called because it's made out of a solid block of material. The photographs on the slide show modelling foam being used, but equally that could be plasticine or clay or a solid lump of wood or something like that. At any rate, a block model is all about the outside form and shape. It has nothing inside, nothing works or anything like that. And it's all about communicating form and shape, testing ergonomics. For example, you may choose to do a block model of a grip or a handle to make sure that it's comfortable to hold. We can present these models to clients. Clients understand them. We can use them to judge aesthetics, work out surface details, and other ergonomic factors such as the position of buttons, the size of dials, etc. like that. Next, we look at a scale model. And a scale model tends to be an enlarged or a miniature version of something. But the whole point about a scale model is that the sizes are dead accurate. Architects love a scale model. They love doing little buildings and white cards, sort of miniature, so that we can see a building in its environment and we can also determine sizes off of it. And the usefulness of a scale model is simply that we can determine information, we can gather information about the sizes of things. Once we know the scale factor or the amount at which the model has been reduced or enlarged, then we can measure the model with an ordinary ruler, multiply or divide by the scale factor to get the real world size of something. So it's great also for checking proportions, for testing ergonomics, for also sort of figuring out assembly methods. And it's definitely useful for marketing, especially around building houses and things like that. Our next model that we're going to look at is a test model. Now, a test model is purely functional. There is no consideration for aesthetics or looks or anything like that. Test models tend to be quite specific as well. They tend to be built for one test in mind. For example, a crash test, or in the example of the photograph there, we've got the model of an aeroplane, presumably going through some sort of aerodynamic wind tunnel testing. So we use a test model to test how well something works, something very specific. We can test efficiency, we can test structural strength, we can test material choice, we can make sure that something conforms to health and safety regulations. And it's a good way to allow us to make changes before manufacture as well. A prototype is also a test model, but it's a step up from a test model, where a test model might involve only one or two very specific functional aspects of a design. A prototype tends to be a functional model of the entire design. So it's a model for testing, but it tends to look at the entire product. A prototype comes out very late in the design process. We use it to prove the viability of a design, i.e. whether it's going to work or not. We can use it to test a fully working product. We can use a prototype to assist with marketing so that the people who are going to promote and sell our product know what's coming. And also, crucially, we can make a prototype so we can test for flaws before the product goes into manufacture as well. And then we move on to computer-generated models. And I think these days, by and large, this is the model type which dominates the product design or the design process. These are fully digital 3D models, and they come out of CAD, CAM or 3D modelling software. They're incredibly useful because they integrate with CAD and CAM systems. Okay, so a 3D model that we make as part of our design can be sent to a CNC machine to be made in a factory. It can be sent to a 3D printer or a laser cutter. We can also take these 3D models and we can run tests and simulations on them, things such as finite element analysis, where we can figure out the structural strength of the components of the model. We can put realistic materials on here and we can generate a realistic render, as it's called. We can make the product look as though it's an actual photograph. That's useful for marketing and promotion reasons. We can also check the dimensions on a computer-generated model, and we can do assembly methods testing as well. We can make sure that no parts are going to foul one another or crash into each other when we're building the thing in real life. So computer-generated models are incredibly popular these days. Now in class we did an exercise on rapid prototyping, which I'm not going to go over in its entirety just now. But rapid prototyping is a concept that came along pretty much at the same time as 3D printing became available, back in the days when it was called stereolithography. And the idea was that a designer could get an idea and very quickly 3D print or rapid prototype his or her idea in real life and test it, and do that many times over a design process. And it really was very quick. It was a game changer when it came in, because instead of you waiting months for a prototype to arrive, you could get a prototype back from a 3D printer in a couple of hours. And it became cheap and it became easy to do and really useful for product design. In terms of the benefits and the drawbacks of rapid prototyping, the benefits are that it was quick to do. We could discover, as designers, what worked about our designs and what didn't work and fix them really quickly, so we could get products to market a lot quicker. They were cheap, so we could save on R&D costs, which meant more profits for the company. The rapid prototyping or the 3D printed model would be very, very accurate. Quite often we could rapid prototype something in the intended material, so we could machine or mill out solid aluminium, or we could sinter or 3D print plastic or metal as well. Rapid prototyping One of the other benefits, benefit 5 there, is that we could make changes really quickly to a design. We could iterate and change our minds quite a lot about a design. And also, as I said before, these things, these machines, these CNC machines and 3D printers, they came into the office and into the design studio. We no longer had to send prototype instructions out to fabrication shops or specialist model makers. It was something we could do as designers in our own studios. But the drawbacks of rapid prototyping, there's a few of them as well. The equipment's very expensive, and the setup of the equipment is very expensive as well. It's not always that easy to use. There are idiosyncrasies with rapid prototyping, so the staff and the designers that are going to use them must be trained in their use. There's only a small number of materials that can be rapid prototyped with as well. We don't have access to all materials, so some material types are limited. If you go for some of the really fancy materials, then they can be quite expensive. And there are accuracy limitations with rapid prototyping. The very fact that they are rapid and quick means that quite often you sacrifice accuracy. You still got a lot of accuracy with it, but for really super accurate stuff, rapid prototyping may not be that suitable. So that concludes our revision on models in the design process. We looked through the 6 types of models. We looked at a way to scaffold an answer towards a past paper. And finally, we've looked at the benefits and drawbacks of rapid prototyping.